In 2025, the Ka-102 concept continues to stand as one of the most ambitious heavy-lift helicopter visions ever associated with the Kamov design philosophy. While it remains a conceptual and developmental platform rather than a mass-produced aircraft, the Ka-102 has become increasingly relevant in discussions about next-generation vertical lift, especially as military and civilian operators demand greater payload capacity, longer range, and improved efficiency in extreme environments. The Ka-102 is often described as a super heavy transport helicopter concept derived from Kamov's long experience with coaxial rotor systems. Unlike conventional helicopters that rely on a single main rotor and a tail rotor for torque compensation, the Ka-102 is designed around twin coaxial rotors mounted on a single mast. This configuration eliminates the need for a tail rotor, allowing more engine power to be directed toward lift rather than stabilization. In 2025, this design choice is once again under the spotlight, as global helicopter developers revisit coaxial layouts to overcome the limitations of traditional heavy-lift platforms. One of the most striking aspects of the Ka-102 concept is its intended payload capability. Early projections placed its internal and external lift capacity far beyond existing heavy helicopters, potentially rivaling or exceeding aircraft like the Mi-26 and specific mission profiles. In 2025, renewed interest in ultra-heavy transport solutions driven by infrastructure projects, energy sector demands, and military logistics has brought attention back to designs like the Ka-102. The idea is not just to lift heavy loads, but to do so efficiently, safely, and with greater operational flexibility. The Ka-102's fuselage concept reflects this philosophy. Rather than a narrow cargo hold optimized only for vehicles, the design emphasizes a wide, modular internal bay capable of accommodating oversized industrial equipment, prefabricated structures, or large military hardware. In 2025 discussions, modularity has become a central theme, with analysts highlighting how a future Ka-102 type aircraft could rapidly switch between cargo, troop transport, disaster relief, and specialized mission roles without extensive reconfiguration time. Powerplant discussions around the Ka-102 have also evolved in 2025. Earlier concept studies envisioned multiple high-output turboshaft engines working in unison to provide the enormous lift required. Today, the focus has shifted toward improved fuel efficiency, digital engine management, and reduced maintenance burden. Advances in engine materials, cooling systems, and FATIC integration mean that a modernized Ka-102 concept could theoretically achieve higher reliability and lower operating costs than heavy helicopters of previous generations. Another major area of attention in 2025 is rotor technology. The coaxial rotors envisioned for the Ka-102 are not simply scaled-up versions of smaller Kamov systems. They are designed to handle extreme aerodynamic loads while maintaining stability during hover and forward flight. With new composite materials and advanced blade aerodynamics now available, analysts believe that many of the technical challenges that once limited such massive coaxial systems are more manageable today. Improved vibration control and noise reduction techniques could also make a future Ka-102 more suitable for operations near populated areas. Flight control systems are another domain where 2025 technology reshapes the Ka-102 narrative. Modern fly-by-wire architectures, augmented by AI-assisted flight stabilization, can dramatically reduce pilot workload. For a helicopter as large and powerful as the Ka-102, this is especially important. In current discussions, the aircraft is often imagined with a highly automated cockpit, capable of precision hovering, automated load stabilization, and advanced situational awareness even in poor visibility or adverse weather conditions. From a military perspective, the Ka-102 concept in 2025 is frequently mentioned in the context of strategic mobility. Modern armed forces increasingly require the ability to move heavy equipment rapidly without relying solely on fixed-wing transport or prepared airfields. A super heavy helicopter based on the Ka-102 concept could theoretically deliver armored vehicles, missile systems, or engineering equipment directly to forward areas. This vertical lift capability remains highly attractive, particularly in regions with limited infrastructure. Civilian and dual-use roles are equally important in the 2025 outlook. Energy companies operating in remote regions such as Arctic zones, mountainous terrain, or offshore platforms have long needed aircraft capable of transporting massive components. The Ka-102's conceptual design aligns well with these requirements. In disaster response scenarios, such a helicopter could deliver heavy rescue equipment, mobile hospitals, or large volumes of humanitarian aid in a single sortie, significantly accelerating relief efforts. The Ka-102's landing gear and structural design also receive attention in modern evaluations. The aircraft is envisioned with a reinforced airframe capable of repeated heavy load operations without excessive fatigue. In 2025, digital structural health monitoring systems are commonly discussed as a way to extend service life and improve safety. Integrated sensors could continuously assess stress and wear, allowing operators to predict maintenance needs rather than react to failures. Noise and environmental impact, once secondary considerations for heavy helicopters, have become critical by 2025. Any future realization of the Ka-102 concept would need to address stricter regulations and public concerns. Advances in rotor blade shaping, engine exhaust treatment, and optimized flight profiles could significantly reduce noise footprint and emissions compared to earlier heavy-lift designs. These improvements make the concept more viable in a world increasingly focused on sustainability. It is also important to note that the Ka-102 is often discussed alongside other Kamov heavy-lift ideas, such as the Ka-92. In 2025, analysts tend to view these concepts as part of a broader exploration of next-generation vertical lift rather than standalone projects. Lessons learned from smaller coaxial helicopters, unmanned rotor aircraft, and experimental platforms all feed into the evolving vision of what a super heavy helicopter could become. The economic aspect cannot be ignored. Developing and producing an aircraft on the scale of the Ka-102 would require substantial investment. In 2025, conversations around such projects emphasize international cooperation, shared development costs, and potential export markets. A future Ka-102 type helicopter would likely be positioned as a global solution rather than a purely domestic platform, appealing to both military and civilian customers worldwide. Training and operational doctrine are another part of the 2025 discussion. Operating a super heavy helicopter demands specialized crews, maintenance personnel, and infrastructure. However, increased automation and advanced simulators could shorten training cycles and improve safety. Virtual and augmented reality tools are now commonly mentioned as ways to prepare crews for complex missions involving extreme loads and challenging environments. When looking at the Ka-102 from a technological readiness perspective, 2025 represents a transitional moment. While the aircraft itself has not entered production, many of the technologies required to make it feasible are either mature or rapidly advancing. High-strength composites, powerful and efficient engines, digital avionics, and sophisticated control systems all point toward a future where such a helicopter is no longer purely theoretical. In the broader context of global aviation trends, the Ka-102 concept aligns with a renewed emphasis on vertical lift capabilities. As urbanization increases and remote operations expand, helicopters are being asked to do more than ever before. The Ka-102 represents an extreme but logical extension of this trend, pushing the boundaries of what rotary-wing aircraft can achieve. In summary, the 2025 outlook on the Ka-102 is less about immediate production and more about strategic relevance. It serves as a benchmark for heavy lift ambitions and a reference point for discussions about future helicopter capabilities. Whether or not the Ka-102 itself is realized in its original form, the ideas behind it continue to influence design thinking, technology development, and operational concepts across the rotary-wing world. As interest in heavy transport, rapid deployment, and multi-role platforms continues to grow, the Ka-102 remains a powerful symbol of what the next generation of helicopters could look like. In 2025, it stands not as a relic of past ambition, but as a forward-looking concept that still challenges engineers, strategists, and operators to rethink the limits of vertical flight.